Hello, welcome. Let's try to solve another Leetcode problem 673, number of longest increasing subsequence. So for this problem, the description is really easy. We are giving integer array nums, and we're going to return the number of longest increasing subsequence. So the difficult part is that we're going to return the number of longest increasing subsequence. We are not only going to find what are going to be the longest increasing subsequence. So for example, in the example 1, it is 4, but also we need to count how many of them. And in this example, there are going to be 2, like 1, 3, 4, 7, and 1, 3, 5, 7. So it's going to be 2. And in this example, it's going to be 5. Yeah. So this is going to be the difficult part. But lucky for us, the length of the nums array is only 2000. Yeah. So this means we can still solve it by using the DB solution, and the pattern is going to be similar to the longest increasing subsequence. We just need to use 2 for loops, as we've already know how to solve the longest increasing subsequence problem. So for example, we have something like 1, 3, 5, 4, 7. Yeah. So definitely according to the DP array, so here we're going to define this F array. So this F array is going to be the longest increasing subsequence. Definitely we know how to calculate this kind of longest increasing subsequence. So for example, here is 1, and for here it's going to be 2, and here going to be 3. Yeah, and this is 4, and this 7. So for this 4, the longest increasing subsequence is going to be 1, 3, 4. It's going to be 3, and for the last one, it's going to be 1, 3, 4, 7, or 1, 3, 5, 7. So here going to be 4. Yeah. So we are not only going to calculate what is going to be the longest increasing subsequence, but we also prepared another array. It's going to be a count. So inside the count array, we're going to count how many of them. So for example, up to here, the longest increasing subsequence is 1, and how many of them? Definitely it is 1. Up to here, it is 2, and how many of them? And definitely it is 1. So the number of the longest increasing subsequence which is equal to 2, how many of them? It's going to be 1. Yeah. So what's going to be the next? So next it is 5. So it's going to be 3. Yeah. And how many of them up to here? So it's going to be 3. And what about this one? 4. And for this one 4, how many of them? It can be 1, 3, 4. Yeah. It can only be 1, 3, 4. Yeah, because we have to include this number 4. So how many of them? Here I did something wrong, I think. So here going to be 1, and here how many of them? Adding with 4, it's going to be still 1. So this going to be the longest increasing subsequence, which is 3, and how many of them? Adding with this number 4, it is 1. Yeah. So what about the last one? Last one, the number is 4, and how many of them? The longest increasing subsequence is 4, and how many of them? As we've already counted, it's going to be 2. So here going to be 2. Yeah. So the difficult part is we know how to calculate the longest increasing subsequence, like this F array, but how can we calculate this counter? How should we know this one going to be 2? Because for here we just count, this one and this one, but how should we know about it? Actually, this going to be the same idea. This 2 is coming from this 3 and this 3 here, as you can see. So here we have a 3, right? And here we have a 3, right? And what about the last number, which is 7? Yeah. So for this number 7, which is more than 4, so this means from here, this one gonna update it. So we're gonna construct the count array as 0. So 0 plus 1 is gonna be 1 here, because we find a number 4. 7 is more than 4. So what about this 5? So 7 is more than 5. We still count it. So this one gonna plus here. We're gonna plus another one. So it's gonna be 2. So this is why how can we calculate? Actually, it is just the same idea like longest increasing subsequence. We just repeat the algorithm of longest increasing subsequence, and then we can use it directly calculating the counter. After calculating the counter, we can directly count it. And how can we count it? First of all, we're going to find the maximum number inside of the F array, which is going to be 4. Yeah. Now we just need to check this index. So for this last index, which is 4, and the number going to be 2, so the final answer going to be 2. Yeah, so this is the basic idea how to calculate it. Maybe some areas, maybe there's going to be another 4. So this means this one going to plus this 2. The answer going to be 3, because there are going to be 2 cases, adding with this number and adding with this number. Yeah. So if you understand the F array and the count array, now let's just start coding. And the coding actually going to be a little bit easier than you expected. Yeah. But how to think about it going to be much more difficult. It seems an easy problem, but actually it is not just so easy. So I'm going to define the length of the number array. A number array is going to be and I'm going to prepare 2 DP arrays. So the first array going to be the longest increasing subsequence array. So I'm going to define it as 1 times n. So the second one is going to be the counter. So for the first number, I'm going to count it directly as 1 because it's adding with this number 1, how many longest increasing subsequence with adding with this number 1, and the length is going to be 1. So the number is going to be 1 as well. Yeah. So it's going to be 1 times. I'm going to define a 0 times n minus 1, because after the first number, I'm going to calculate how many of them, and there are going to be edge cases, such as the second example. That is why I'm going to define it like this. It's going to be a little bit difficult to understand, but after the following lines of coding, you're going to understand why I'm going to define the counter as 1 plus 0 times n minus 1. So for the first one, definitely it's going to be a 1. And how many of them adding with this one, it's going to be 1. Adding with this 2, it's going to be 1. But for others, I'm going to calculate according to the DP solution. Yeah. So now let's just start the basic pattern of longest increasing subsequence. So for I in range 1 to n, and here for j in range I. So how to calculate the longest increasing subsequence? It's going to be easy. So if here we're going to use if condition, if number j is less than number I. And because here said it's going to be strictly increasing. It is strictly increasing. This means we're going to use a less than, not equal. Yeah. So we're going to update the F array. So Fi going to be the maximum of Fi with Fj plus 1. And this is just the longest increasing subsequence pattern. I thought everyone gonna understand how we're gonna code it like this. Yeah. Now we're gonna check this count array and how to update this count array. This is gonna be a little bit difficult, but actually it is not so difficult after I analyze the drawing before. Yeah. So it's gonna be the same pattern. Let me just copy the code from here. Yeah, it's going to be similar. So for j in range I, if nums j less than nums I, and we're going to check the condition. If there's a condition, so we're going to update it. So the condition is we're going to use this F array. So if Fi equal to Fj plus 1, so this means definitely there's going to be a valid case. So we're going to update the counter. So nums I going to plus equal to count I plus equal to count j. Yeah, but there's going to be an edge case. So for in the second example, for example, this is number 2, this is number 2, we can never find it. So this means at those positions for the count array, it's going to be 0, but it can never be 0. If it is 0, we're going to set it to 1. This means adding with this number 2, the longest increase in subsequence is 1, and how many of them? It's going to be 1 with this position, adding with this number 2. Yeah. So we're gonna check it. I think this gonna only be the only be the difficult part. If we understand this, definitely we understand why we're gonna define this F array. Yeah. So we're gonna set it as 0 as our edge case, because from here we're gonna check it. So if count I equal to 0, we're gonna set the count I onto 1. Yeah. Now we've already finished the main part of the coding. We just need to return the final result. Here we're going to use the maximum number. So this maximum number is going to be the maximum of F array. It means the longest increasing subsequence. And then we just need to check how many of them. And how can we check it? It's going to be inside the count array. So we're going to use a sum with count I for in enumerate the F array if this number equal to the maximum number. yeah, here we just use this counter to count how many of them. Now let me just look if it works. Yeah, at the same time, let me just check my coding if there's anything wrong about it. It's gonna be, yeah, I did something wrong. I don't know why. Yeah, actually, it should be 5, but I did it as 1. So, yeah, let me just check the coder. Create code and F array. So the coder is 100. Definitely the coder is wrong. The F array is okay. As we can see, it is always to be a 1. It means adding with this number, the longest increasing subsequence is 1. But the coder is wrong. This is why I did it wrong, because I should use a single equal instead of double equal. This is a typo. Yeah. Now let me just run it to check if it works. Now as you can see it works, and now let me just submit it. As you can see, it passed for all testing cases, and yeah, just ignore the speed. I think it is okay for 1 second, and because definitely we are allowed to use O squared time complexity for this problem, because n is just 2000, so the final time complexity is gonna be 10 to the power of 6. I think that's all about it. Thanks for watching. See you next time.